Hi everybody! In this video, we are going to be talking about factoring a squared minus b squared binomials using the difference of squares formula. So if we think about our factoring flowchart, again, we are still always going to see if we can find a greatest common factor, but here we're going to be looking at the two terms polynomials, and specifically when it's in the form a squared minus b squared. So that's what we're talking about today. All right, so here's our formula. If you have something in the form a squared minus b squared, you can always factor it into parentheses a plus b times parentheses a minus b. It's a pretty easy formula, so if you guys want to put it in your brain right now, take a few seconds. A plus b times a minus b. Okay, so there's a few requirements before we get started. First things first is that both of those terms of that binomial need to be perfect squares. And what I mean by that are two of the same values being multiplied together. They can be numbers, or they can be variables, or some combination of both. They just need to be perfect squares. And then secondly, there has to be a subtraction right here. If it's a plus, this formula will not work. Okay, let's go ahead and look at an example. So we have x squared minus 25. So first things first, I noticed that there are two terms. I'm going to see if I can factor out a greatest common factor. Nothing, I can factor out nothing, so I'm going to go on to use this formula. I want to find my a and b value so I can plug it into the formula. So to do that, I'm going to look at x squared. Now I'm going to ask myself, what times what would give me x squared? Well, I know x times x would give me x squared. Since they are the same, it is a perfect square. So my a value is x. And I'm going to do the same thing for 25. Notice that this negative here is from our formula. Don't worry about the negative, just worry about the 25. Again, what times what would give me 25? 5 times 5 would. It is a perfect square, so my b value is 5. Now that I have this formula, all I'm going to do is plug in x for a and 5 for b, and I have my answer. Y'all, that is it. That is as simple as it gets. You can always check your answer. If you want to multiply these two together, you should get x squared minus 25. So that's kind of nice. You can always check your answer. All right, we're going to bump it up a little bit. Sometimes you're going to get something that looks like this. We are always going to, again, start with our greatest common factor. I don't see anything that I can factor out, so I'm going to go ahead and see if I can do my difference of squares. I'm looking at 49. Look at your number first. I'm like, hey, I know that 7 times 7 gives me 49. So it kind of looks like a perfect square. But now I have to worry about this x to the 6. I'm like, 6 is not a perfect square, but I have to remember that when you are multiplying variables with exponents, you are actually adding the powers. So I want to find two numbers that add to 6. So in this case, it is a perfect square because x cubed times x cubed will give me x to the 6th power. So that's kind of a little bit different there. So if you want to write yourself a note when you're doing exponents, make sure you're adding together, not trying to multiply to 6. Okay, let's go into the next one. A value is 7x cubed. Next one, start with your number 9. I know 3 times 3 will give me 9. What times what will give me y squared? Well, y times y would give me y squared. So there is your b value. Again, here's our formula, a plus b times a minus b. Plug in your a, plug in your b. Bada bing, bada boom. That is it. You have factored it. So something I want you guys to notice is that, remember how I said it always has to be a negative in between right here? If you ever see a positive and it is adding those perfect squares together, your answer is always going to be prime. There is no way that you can factor this any further. So if you ever see two squares being added together, you can stop right there and be like, hey, that's prime. Okay, so some final thoughts. If you guys will look over this perfect squares kind of formula chart, it'll kind of help you guys to recognize when to use the difference of squares formula. So if you see a 4, a 9, a 16, that might be a good indication if you only have two terms that you could maybe use the difference of squares formula. So this is here for you as reference. If you guys have questions, let me know. Other than that, I'll see you in the next video.